For centuries, humanity operated under a single, flawed assumption that our solar system was the standard. We looked at the orderly procession of planets around our sun, rocky worlds close in, gas giants further out, all moving in stable, predictable timeframes, and assumed the rest of the galaxy followed the same rules. We were wrong, as our telescopes have peeled back the darkness of the Milky Way, revealing over 6,000 confirmed exoplanets. We have learned that our home is not the rule. It is the exception. The galaxy is not filled with orderly, habitable gardens. It is populated by monsters, ghosts, and anomalies that defy our understanding of physics. We have found worlds where time moves so fast, a year lasts only hours. Worlds that are being eaten alive by their own stars, and worlds drifting alone in the eternal blackness. To understand the true scale of the galaxy's strangeness, we have to abandon the safety of Earth and look at the places where the laws of nature seem to have broken down. The first thing that shatters our understanding of a normal planet is the concept of weather. On Earth, extreme weather might mean a hurricane or a blizzard. But in the constellation Pisces, about 640 light years away, lies a planet that redefines the word hell. It is known as WASP 76b. To the naked eye, it might look like a typical gas giant, but this world is tidally locked. One side faces its star forever, baking in eternal daylight, while the other is frozen in eternal night. The dayside temperatures climb above 2,400 degrees Celsius. This is hot enough to literally vaporize metal. Molecules of iron in the atmosphere are blasted apart, carried by screaming winds across the Terminator line into the cooler night side. There, the iron condenses, turning from gas back into liquid. If you were standing on the night side of WASP 76b, you wouldn't look up to see rainwater. You would look up to see a torrential downpour of molten iron. But even WASP 76b is stable compared to the violence found elsewhere. In the search for the most hostile environment in the galaxy, we eventually find Kelt 9b. This planet orbits a blue A-type star that is nearly twice as hot as our sun. The planet sits so close to this inferno that its surface temperature reaches over 4,300 degrees Celsius. That number is significant because Kelt 9b is hotter than most stars in the universe. It is a planet with the temperature of a red dwarf. The heat is so intense that molecules cannot hold together. Hydrogen gas is torn apart into its atomic components. The star is blasting the planet with such ferocity that Kelt 9b is effectively evaporating, its atmosphere stripped away and trailing behind it like the tail of a comet. It is a world being slowly, agonizingly deleted from existence. However, heat is just one metric of strangeness. A planet can be strange simply because of its sheer impossible scale. When we look at Saturn, we see the jewel of our solar system. Its rings are iconic, but they are merely a speck of dust compared to the object known as J1407b. Located over 400 light years away, this object, which may be a massive planet or a brown dwarf, possesses a ring system that defies logic. Its rings are not just large, they are colossal. They span a diameter of 120 million kilometers. If you replace Saturn with J14407b, its rings would dominate Earth's sky, appearing many times larger than a full moon. They are 200 times larger than Saturn's rings. In fact, if you place the center of this system at the sun, the outer rings would extend almost all the way to the orbit of Venus. It is a structure of such immense scale that it challenges our models of how planetary systems form. Yet even these giants follow a recognizable pattern, a planet orbiting a star. But what happens when you change the math? What happens when you remove the single sun and replace it with 2, 3, or even 7? In our neighborhood, gravity is simple. One star dominates. But deep in the galaxy, we have found systems that look less like clockwork and more like chaos. We have observed planets caught in the gravitational web of multi-star systems. The most famous fiction gives us the twin sunsets of Tatooine, but the reality is far more violent. In a system with 3 or 4 stars, the orbital mechanics become a nightmare. A planet in such a system wouldn't have stable seasons. Depending on its position relative to its host stars, it might experience decades of freezing winter followed by sudden, scorching summers tremors as it swings close to a second or third sun. The radiation levels would fluctuate wildly, sterilizing the surface. We have run simulations adding just a small second star to our own solar system. The result is catastrophic. The delicate gravitational balance that keeps Earth in the habitable zone would shatter. We would be thrown out of orbit, either to freeze in the dark or burn in the sun. These multi-star worlds exist on a knife edge of stability, constantly pulled by opposing forces. But there is a fate worse than having too many stars. It is having none at all. This brings us to the most unsettling category of exoplanets, the rogue planets. These are the ghosts of the Milky Way. Planetary bodies that have been ejected from their home systems, kicked out by gravitational interactions, and sent drifting into the void between stars. They orbit nothing. They have no sunrise, no sunset, and no years. They simply float through the crushing dark. For a long time, we thought these were rare. Now, astronomers suspect there may be billions of them, perhaps even outnumbering the stars themselves. We find them using a technique called gravitational microlensing. Since they emit no light, we can only see them when they drift directly in front of a distant background star, their gravity briefly bending and brightening the star's light. The terrifying part of a rogue planet is not just the darkness, but the possibility of what lies beneath. While the surface is frozen near absolute zero, the core may still be molten. A rogue planet with a thick, insulating atmosphere could trap that internal heat. It is entirely possible that on a world without a star, drifting in absolute blackness, there are liquid oceans beneath a thick crust of ice. And in those oceans, fueled by volcanic vents rather than sunlight, life similar to Earth's deep-sea organisms could exist. They would be blind ecosystems, living and dying without ever knowing the universe contains stars. Finally, we arrive at the strangest phenomenon of all, the distortion of time itself. On Earth, a year is a fixed concept, 365 days. But we have discovered planets where a year lasts only a few hours. These are the ultra-short period planets, worlds that skim the surface of their stars, completing an entire orbit in the time it takes to watch a movie. But the most extreme versions of these are the pulsar planets. Pulsars are the corpses of massive stars, spinning neutron stars that emit beams of radiation like a cosmic lighthouse. They are incredibly dense and violent. It was assumed no planet could survive the supernova explosion that creates a pulsar, yet the very first exoplanets ever confirmed were found orbiting one. These are zombie worlds, bathed in constant lethal radiation. The gravity of the pulsar is so intense, and the orbits often so fast, that the time dilation effects, though microscopic, are real. But physically, these worlds are being destroyed. Some are slowly vaporized by the pulsar's beam, while others are essentially the crystallized cores of white dwarfs, massive diamonds the size of Earth, trapped in a radioactive dance of death. From the iron rains of WASP 76b to the lonely drift of rogue planets, the Milky Way has proven to be far more creative and far more terrifying than we ever imagined. We used to look for Earth-like planets because we thought they were the standard. Now we know that Earth is a rare oasis in a desert of extremes. There are over 100 billion stars in our galaxy alone. We have looked at only a tiny fraction of them. If the first 6,000 planets have shown us worlds this bizarre, one has to wonder what is waiting for us in the darkness that we haven't seen yet. The universe is not just stranger than we imagine. It is stranger than we can imagine. If you want to join us as we continue to map the unknown, make sure to subscribe and turn on notifications. The galaxy is a big place, and we are just getting started. Thanks for watching.